Let's take one more. Show that the volume of the greatest cylinder that can be inscribed in a cone. So greatest means maximum. Cylinder is inside a cone of given height. So cone's height is a constant and the semi-vertical angle of the cone is alpha. We want to show that the volume of the cylinder is 4 upon 27 pi h cube tan square alpha. Let's draw the figure. Let's draw a cone, and inside the cone we will draw a cylinder. Height of cone is given to us as h. We can take this height of cone as h. This is h. And let's take the radius of the cone as say r. This is h. Let's take radius of the cone as r. So this length, let's draw this perpendicular. So this is 90 degree. This can be marked 90. We can take now radius of the cylinder here. Say it is r. This is 90. This angle is alpha given by them, semi-vertical angle. This is alpha. And let this height of the cylinder be h. Therefore, the above height of that smaller cone that you are seeing, the remaining height is h minus h. By similarity of triangle, we know triangle A, B and C is similar to triangle A, P and Q, 90 each and common angle. So if the two triangles are similar, the ratio of their radii, that is r upon r, is equal to ratio of their heights, which is h upon h minus h. We want to maximize the volume of the cylinder. Volume of the cylinder is given by pi r square h. To remove one of the two, either r or h, let's say removing h looks easy. So we can write pi r square times h. And h can be obtained from here. H minus h is equal to RH upon r. So h would be equal to h minus RH upon r. Let us substitute it here. H minus RH upon r is equal to, when we multiply this, we get pi r square h minus pi r cube h divided by r. The cone was already given, height is given, alpha is given, so radius is also a constant here of the cone. Let's differentiate with respect to capital R, which is the radius of the cylinder. So we get dV upon dr. Let's write here dV upon dr is equal to 2 pi RH minus 3 pi r square h upon r. Let's equate it to 0. This gives us 2 pi RH is equal to 3 pi r square h upon r. Let's see if we can cancel out pi. One of the radius of the cylinder gets cancelled, height of the cone gets cancelled. We are left with one relation, that r is equal to 2r upon 3. This is one result that we are getting of the first derivative. We know second derivative is the norm that you have to do. Let's take second derivative. d square v by dr square, this answer should come out as negative. अगर ये नेगेटिव आता है तो ही हम इसको मैक्सिमा या ग्रेटेस्ट बोल पाएंगे. We differentiate from here. So 2 pi RH derivative is 2 pi h minus 3 pi h into 3 pi h into 2r, as r square's derivative is 2r, the whole upon r. This is 2r. This r can be replaced as 2r upon 3. So we get 2 pi h minus 6 pi h into 2r upon 3. In place of capital R, we are writing 2r upon 3. 3 2s are 6 upon r. Let's cancel out r. We can cancel out 3 2s are 3 1s are. We are left with 2 pi h, which is equal to minus 2 pi h, which is less than 0. So we can call now V as greatest. V is greatest or maxima when r is equal to 2r upon 3. Let us substitute this r as 2r upon 3 here in this relation, and let us get h. So we get h is equal to h minus this capital R is 2r upon 3 into h by r. This h by r is remaining. We cancel out r is equal to h minus 2h upon 3, h minus 2h upon 3. Clearly, we have got the height of the cylinder as equal to h upon 3. When you LCM this, you get h upon 3 as the height of the cylinder. Now, when you look at this triangle ABC, we can get tan alpha, because see, in the question we are asked to write the answer in tan alpha form. So tan alpha would be equal to BC upon AB. BC is equal to R, we know that, and AB is H minus H. So we can see, so we get here R upon H minus capital H, and this is R upon H minus H by 3. So tan alpha is equal to R upon 2H upon 3, which gives us R is equal to 2H upon 3 tan alpha. Let us write now volume of cylinder, which is given by pi r square h is equal to pi into r square. We have just got r as 2h upon 3 tan alpha. So its square will be 4h square upon 9 into tan square alpha times h. H is h by 3 here. So we write here into h by 3. Let's multiply this and we get volume of the cylinder as 9 3s are 27. So 4 upon 27 pi h square into this h is h cube and tan square alpha here. That's what is asked. Prove that volume of cylinder is this much. Show one more. Show that the height of the cylinder of greatest volume, similar language to the previous one, which can be inscribed in a right circular cone. So cone is outside and the cylinder is inside, and cylinder's volume needs to be maximized. Then we have to show that the height of the cylinder is 1/3 to that of the cone. Don't think we need to solve this. We have just done this sum a while back. Let's see that solution which we just did. And you have to repeat everything what we did so far up to here, and then get the answer as height of cylinder is equal to h by 3. Small h is h of cone. See, we have shown. So you don't have to write after tan alpha whatever is coming. So you can refer the same sum which we did a moment back for as the solution for this sum. Correct? So we have to prove that h is equal to h upon 3. Let's take another question. Find the volume of the largest cone that can be inscribed in a sphere of radius r. Let's begin by drawing a sphere, and within the sphere we have to draw a cone whose volume has to be maximized. But because sphere is given information to us, its radius can be taken as constant. What we mean by that is that when we draw the radius of this sphere, we can take it as a constant. Even this can be called as radius of sphere. So could the joining of this also. Let's name this radius of sphere, say as r. This r is a constant for us. Let us complete this height, and let us call this height, this length that we are just dropping perpendicular here, say as x. Clearly, we are able to see the formation of a right angle triangle here, and therefore by Pythagoras theorem, this radius of the cone will be root of r square minus x square, hypotenuse square minus adjacent side square. We have also got the height of the cone in terms of x. Height of the cone is r plus x. We are ready to write down volume of cone. Volume of cone formula is pi r square h. Let's begin. V is equal to pi r, we just got, okay, let us write pi r square h, and we just got the radius of the cone as root r square minus x square square times height, and height is r plus x. We are talking about the cone's height, r plus x. The root will go, it will become equal to pi times r square minus x square into r plus x. R is a constant, capital R. We have to differentiate with respect to x. Either we can multiply and then derivate, or we can directly. Let's this time directly derivate with respect to x. So v dash is equal to pi into product rule लगेगा, r square minus x square into derivative of r plus x is 0 plus 1 is 1 plus r plus x into derivative of r square minus x square will be 0 minus 2x. And what do? We equate this derivative, pi is multiplying with throughout the derivative, we equate the derivative to 0. Let's see, what do we get as x? So pi gets divided by 0, it goes. Remaining quantity is r square minus x square. This is r square minus x square minus 2rx minus 2x square is equal to 0. Looks as if we will have to factorize. So this becomes r square minus 2rx minus 3x square is equal to 0. By splitting the middle term, this gives you r square minus 3rx plus rx minus 3x square is equal to 0. R common, r minus x common, r minus 3x is equal to 0. Therefore, r minus 3x into r plus x is equal to 0. Clearly, r is equal to 3x or r is equal to minus x is rejected as radius cannot be negative. So r equal to 3x looks okay. We now get x as equal to r upon 3. We know this step is an essential thing in second order derivative, that is the second order derivative, and we need to show that the second derivative is negative. Let us remove this figure, not required now, and let us take the second derivative. So second derivative becomes equal to, we take the second derivative from here. So we get v double dash is equal to pi times, we are differentiating from this step, r square minus x square derivative is minus 2x plus r plus x into minus 2x derivative is remaining. Let's apply product rule there. So it is plus r plus x into minus 2 plus minus 2x into derivative of r plus x here is 1 is equal to pi times minus 2x is minus 4x plus minus 2 into r is minus 2r plus x into minus 2 here, plus x into minus 2 is also minus 2x. Clearly this entire quantity is less than 0. This implies that v is largest or maxima. X is equal to r upon 3. They have also asked us to find the volume of such a cone. So volume of cone is equal to 1 upon 3. We know the formula is here. This is the formula for volume of cone that we have. We had to write it for the largest cone. The cone's formula will be 1 by 3. We missed out that part. We are rectifying it. And this is 1 by 3. But 1 by 3 on cross multiplying with 0 will go off, and therefore our answer x is equal to r by 3 is correct. Let's write this 1 upon 3 pi into r square minus x square. This form we are trying to write, which is r square minus x square. X is r by 3 here, which will be r square by 9 into r plus x is r plus x is r by 3 is equal to 1 by 3 pi into LCM is 8r square upon 9 into 3r plus r is 4r upon 3. We get the result as equal to 4 8s are 32. This is 81 pi r cube, r square into r. We can also write this as 8 upon 27 times 4 upon 3 pi r cube. The reason is 8 4s are 32, 27 3s are 81, and 4 upon 3 pi r cube is a formula for sphere. So 8 upon 27 times volume of sphere. This way also we can ask the question. This is the extra step that we have written. In exam, it was only asked us to write the volume of the largest cone. So we could have stopped at 32 upon 81 pi r cube. This is additional information in case the question is asked in this way. One more question. There are many questions in this topic of word problem nature which students find difficult. So I'm trying to do whatever maximum we can. That's why not missing out. Let's take up one more. An open box with a square base. The base is square, that's given to us. So we can take base as x, length of side of square, so area will be x square. Is to be made out of a given quantity of cardboard of given area c square square units. Show that the maximum volume of the box is c cube upon 6 root 3 cubic units. This is what we want to prove. Maximize करना है volume of the box. वैसे box जो school में हम पढ़ते थे, it's nothing but the lateral surface area of 4 walls and the floor, because the box is open from the top and the height is h. Then we know that c square is nothing but x square, that is base of square का area plus 4 walls का lateral surface area हो जाएगा 4xh और y is equal to c square. So let's get the height of the box in terms of c and x. So c square minus x square, ये x square पहले यहाँ लिया, divided by 4x. Do not differentiate this. This is given quantity. We now start with volume of the box that has to be maximized. Volume का formula होता है box का LBH. LB x है, BB x है, तो x square into h. But h के जगह हम लिखेंगे c square minus x square divided by 4x. x एक हट गया. We can multiply and then differentiate. We get c square x minus x cube divided by 4 as the volume of the box. So v dash is equal to c differentiate. We get v dash is equal to c square into derivative of x is 1 minus x cube's derivative is 3x square divided by 4 is equal to 0. On cross multiplying, we get c square minus 3x square equal to 0. This gives you 3x square is equal to c square. Therefore, x square is equal to c square upon 3. So x is equal to c upon root 3. We will take positive root only, as x was the length of side of square. We now continue with second derivative. V double dash is equal to c square derivative is 0 minus 3x square derivative is 6x upon 4. And when you substitute x as c upon root 3 upon 4 into c upon root 3, and this value is less than 0. This is enough to conclude that V is maximum. V is maximum when x is equal to c upon root 3. Let's now get formula for volume of the open box, which is x square h is equal to x square, we know, is c square upon 3. We can see here. So we can write c square upon 3 into h. H we know from equation 1 is c square minus x square. X square here we just saw c square by 3 upon 4x, 4 into c upon root 3. We can work this out now. One of the c cancels with this c. Then root 3 and 3 can cancel out. So root 3 cancels out, and here 3 cancels out and becomes root 3 in denominator the way you want it, is equal to c upon root 3 into 2c square upon 3 divided by 4. 2 ones are 2 twos are 3 and 2 now multiply and become 6 as you wanted. C square into c becomes c cube. So c cube upon 6 root 3 cubic units is the volume of the open box, which is maximum. The next one, ये थोड़ा सा easy है compared to previous few questions. पाओगे ये. The right circular cylinder is to be made so that the sum of its radius and height is 6. So both radius and height are not constants, they are variables, but उनका total constant है, which is 6 meters. You want to find the maximum volume of the cylinder. So पिछले थोड़े सम्स में ऐसा हो रहा था, कोन के अंदर सिलेंडर, स्फीयर के अंदर कोन. Then last sum was about the cuboid. This time we have cylinder, a single object. Let's write R plus H is equal to 6 meters. Equation 1. To find the maximum volume of the cylinder, the formula is pi r square h. किसी एक को निकालते हैं, या तो R को या H को. चलो H को निकालते हैं, कुछ नहीं है H में. So we can write H as 6 minus R from equation 1. See, H is 6 minus R from equation 1. Let's multiply this. So 6 pi R square minus pi R cube is our volume function in R. So V dash यानी dV upon dr is equal to 12 pi R minus 3 pi R square, and we equate it to 0. We therefore get 3 pi R square is equal to 12 pi R. Pi can get cancelled. R can get cancelled as it's a non-zero value. You can cancel it. So we are left with R is equal to 4 meters. Let us now take second derivative. V double dash is equal to 4 कैसे आया? 12 upon 3 किया. V double dash is equal to, let's take derivative from this step. 12 pi r का derivative is 12 pi minus 3 pi r square का derivative is 6 pi r. R में 4 डालना है, is equal to 12 pi minus 6 pi into 4 is equal to, this is manageable and we should get a negative answer, तो ही maximum बोल पाएंगे. V is equal to 12 pi minus 24 pi, which is minus 12 pi, which is less than 0. Once you write less than 0, then conclude karo. This implies that V is maximum when R is equal to 4 meters. Substitute R is equal to 4 meter in equation 1. So from equation 1, we get 4 plus H is equal to 6. Therefore, H is equal to 6 minus 4 is equal to 2 meters. We are asked to find the volume of the cylinder. Volume is pi r square h. Pi into r is 4, so 4 square into h is 2. 4 square 16, 2s are 32. So we get 32 pi cubic meters. This is your answer. cubic meters. This was easy. Here in the next question, show that the height of an open cylinder is open from the top, of given surface area. So far we have been dealing with volume. This time the surface area is given, except in that cuboid question where we had 4 walls and the base. Here again the surface area is given and we have to show and that this object has got the greatest volume. अब वॉल्यूम करते वक्त सिलेंडर का इवन इफ इट इज क्लोज्ड और ओपन द वॉल्यूम फॉर्मूला रिमेन सेम पाई आर स्क्वायर एच and they are saying that the height of the cylinder is equal to the radius of the base, यानी height and radius equal हो जाते हैं end में. ठीक है, first thing first, let's write down the given surface area. We know given surface area of open cylinder is एक तो pi r square होगा base में if radius is r plus curved surface area of cylinder is 2 pi r h 10th में पढ़ा होगा ये formula is equal to this value is given to you and let us say we call this as say k. You can take any constant of your choice, say we take it as k. पिछले सब में 6 meters दिया था, यहाँ पे कुछ बोला नहीं है तो let's take it as k. We can get h is equal to therefore k minus pi r square divided by 2 pi r. पहले हमने pi r square यहाँ लिया and then 2 pi r को divide करा दिया. Let this be called equation 1. We want to now get volume formula and volume formula for cylinder is pi r square h. Let it be open or closed. अगर ये closed होता तो हमारा यहाँ pi r square के जगह पे आ जाता 2 pi r square. But यहाँ पे तो open है. Let's write down the formula for volume, which is pi r square h is equal to pi r square times h is k minus pi r square divided by 2 pi r. अगर कुछ कैंसिल होता है तो कर देते हैं, जैसे पाई पाई one of the r cancels out. So let's multiply the numerator. Only r multiplies now. So we get kr minus pi r cube whole divided by 2. This is a volume function. Let's differentiate with respect to r. So v dash is equal to k minus 3 pi r square divided by 2 is equal to 0. We can cross multiply. So we get k minus 3 pi r square, k minus 3 pi r square is equal to 0. Clearly, k is equal to 3 pi r square. So r square is equal to k upon 3 pi. Let us now substitute this in first let's take second derivative and then think about substitution. So we get this as root k upon 3 pi. We differentiate one more time. V double dash is equal to k's derivative is 0 minus 3 pi r square's derivative is minus 6 pi r divided by 2, which is less than 0. We conclude V is therefore greatest. Volume greatest हो गया किसका? सिलेंडर का. When r is equal to root k upon 3 pi. Let us try to write down formula for volume. Volume is equal to, but हमें पूछा क्या था? That वॉल्यूम नहीं, हमें पूछा है कि हाइट को रेडियस के बराबर है वो बता दो खाली. तो यहाँ इक्वेशन 1 में चले जाते हैं. h is equal to k is 3 pi r square. We can see here, so we can write here 3 pi r square In place of k, we are writing it from in this equation 1 minus pi r square divided by 2 pi r. Let's write here from equation 1 is equal to 2 pi r square divided by 2 pi r. We have a cancellation of common factors. 2 gaya, pi gaya, even r का एक factor gaya, and we are gradually reaching to our desired result. Therefore h is equal to r. वही हमें पूछा था कि प्रूव करके दिखाओ कि height of the cylinder is equal to radius of the cylinder for maximum volume. Taking up one more. A closed right circular cylinder or has a volume of 2156 cubic units. So volume is constant. What should be the radius of the base? Radius is asked of the base of the cylinder so that the total surface area TSA of cylinder is minima. Use pi as 22/7. First thing first, we know volume of cylinder is pi r square h. So pi r square h is equal to 2156. We can leave this as equation 1. We should not differentiate this as it is given quantity. We have to minimize the TSA of the cylinder. Formula for TSA of cylinder is, let us write A as the area, is equal to 2 pi r square plus 2 pi RH is equal to 2 pi r, we can take common, and r plus h we can write, or 2 pi r square. We know pi r square like this we can write, and h के जगह पे यहाँ से इक्वेशन 1 से हम लिख सकते हैं, h के जगह पे इक्वेशन 1 से हम लिख सकते हैं 2156 divided by pi r square. This is from equation 1 we are writing from 1. बेसिकली हम एक r का फंक्शन बना रहे हैं, पाई हटा 1 r factor also gets cancelled. We are ready to differentiate with respect to r. E dash is equal to 4 pi r minus 2 into 2156 upon r से derivative is r square. We know 1 by r derivative is minus 1 by r square is equal to 0. Therefore 4 pi r is equal to 2 into 2156 divided by r square. We can cross multiply r square. We get r cube now. So r cube is equal to 2 into 2156 divided by 4 pi, which is 4 into 22/7. We know 2156 is divisible by 11 as sum of alternate digits are 7, 7. 7 minus 7 is 0. So number is divisible by 11. 11 twos are 11 ones are. Then 105 में 99 में 9 times, and then 66 में 6 times. We can also reduce this further and write 2 ones are 2 98s are, then 2 ones are 2 twos are. We still have a scope to cancel 2 ones are 2 49s are. So we end up with r cube is equal to 49 into 7, which is 343, it's a small number, we can directly multiply, and its cube root is therefore 7 units. We have got the radius. That's what they have asked. What should be the radius of the base? We have got that. But in exam, do not forget to take second derivative to show that the surface area was minimum. So we write a double dash is equal to, we go here at this step and differentiate. 4 pi at this step, 4 pi r derivative is 4 pi. 1 upon r square डेरिवेटिव में पहले r रेस टू -2 होगा एंड फिर डेरिवेटिव करोगे तो माइनस ऑफ माइनस प्लस हो जाएगा. सो प्लस 2 इंटू 2156 तो है ही, इंटू 2r रेस टू -3 which is 2 upon r cube. When you put r as 7 here, so we get 4 pi plus 2 into 2156 into 2 upon 7 cube. We know this answer is greater than 0. If this answer is greater than 0, we can conclude that A is minimum. R is equal to 7 units. ये R लिखा है यहाँ पे. R is equal to 7 units. This is your answer. Let's do one more. The lighthouse is located at point A, 2 kilometers offshore from the nearest point O on a straight beach. So lighthouse is inside the beach somewhere, and a shop is located at B. Shop is we assume that it is along the beach. Let's read further. So lighthouse is 2 kilometers inside. The shop is located on the beach 4 kilometers distant from point O. If the housekeeper can row at the rate of 4 km per hour and walk at the rate of 6 km per hour, so rowing speed is 4 and walking speed is 6, walking is faster, where should he plan to reach the shore so as to cover the distance in the least possible time? So he has to cover the distance in least time. That's what is the question. Let's understand this question by a figure. Say we assume that the lighthouse is here. Let's call it, say, as L. This is your point O. This is the fastest way to reach to the beach. This is his shop, say S. Let's say after rowing he has reached here at point say P. Now to understand this logic, the story is like this, that he's rowing along this path. So यहाँ पे पानी है and he's rowing along this path LP. After he reaches the beach, he walks along the beach from P to his shop. So ये कम से कम टाइम में पहुंचना चाहिए, ये क्वेश्चन है. यहाँ पे उसकी स्पीड है 4 किलोमीटर पर आवर, यहाँ पे उसकी स्पीड है 6 किलोमीटर पर आवर. ये वॉकिंग स्पीड है. अब कोई सोच रहा है सर फिर वो ऐसे ही चल के ऐसे क्यों नहीं आ रहा है? It would have taken him more time. So definitely he wants to cut down his time of rowing and walking. This distance is given to you as 2 kilometers. This total distance along the beach from O to your shop, his shop, is 4 kilometers. This is 4 kilometers. We are talking the distance part. That's given to us 4 kilometer here in the question. And let this be x kilometer OP, and therefore PS would become 4 minus x kilometers. Total minus x is PS length, and LP can be obtained by Pythagoras theorem. LP can be obtained by Pythagoras theorem. This is LP length, which is root of let's write it here, root of x square plus 2 square. And we know distance upon speed is time, so we are trying to create the time function. t is equal to, distance is root x square plus 2 square, 2 square is 4, divided by speed is 4 kilometer per hour, plus 4 minus x is the distance, and at that time the corresponding speed was 6 kilometer per hour. So we have formed the time function. Let's differentiate with respect to x. Therefore, t dash is equal to, derivative is 1 upon 4 into 2 root x square plus 4 into derivative of x square plus 4 is 2x, plus 4's derivative is 0 minus x derivative is 1 upon 6, and we equate this to 0. We can further simplify this and try to get x. 2 cancels out, so we get x upon 4 root x square plus 4 equal to 1 upon 6. Let's square both sides. So x square and 6 square is 36. So 36x square is equal to 16 4 ka square times x square plus 4. Therefore, 36x square is equal to 16x square plus 64. We simplify this further. On subtraction, we get 20x square. So 20x square is equal to 64. We have subtracted 16x square. So x square is equal to, we can divide by 4. So it is 16 upon 5. We are dividing by 4. 4 16s, 4 5s, and 16 upon 5 is 3.2. So x is equal to square root of 3.2, which is approximately x is equal to 1.789 kilometer. And that's what we wanted to know. If he wants to cover in least possible time, but for least we will have to show second derivative. That's formality that's still remaining. Let's take the derivative of this x upon 4 root x square plus 4. We are talking about this part. So denominator u upon v rule 1 by 4 को बाहर रख देते हैं. U upon v rule is denominator x square plus 4 into derivative of x is 1 minus x into derivative of root x square plus 4 is 2x upon 2 root x square plus 4 upon denominator square is x square plus 4. Constant 4 we have anyways taken out. Minus 1 by 6 derivative is 0. Now here let us substitute x square as or x as 3.2, and we should be getting a negative answer. So when you substitute x as 3.2, we get 1 upon 4 into x square being 16 upon 5. If you write 16 upon 5 here, so you get, instead of substitution, we are writing root x square plus 4 minus x square upon root x square plus 4 divided by x square plus 4, like this. Let's finish off this. Let's remove this figure, not required anymore. We remove this figure and finish this derivative here only. We have to show that it is going to be positive. This derivative answer should look positive. So t double dash is equal to, we are continuing, 1 upon 4 times LCM ले लेते हैं, x square plus 4 minus x square divided by root x square plus 4 divided by x square plus 4. Clearly x square cancels out. We can even cancel this 4 with this 4. The leftover quantity is positive, so it is equal to 1 upon, we can write x square plus 4 raised to half, and this degree is 1, half and 1 become 3/2. So t double dash is definitely greater than 0 because x square भी है यहाँ पे तो positive ही रहेगा. Therefore it implies that t is least when x is 1.789 kilometer. So if you reach the shore at 1.789 kilometer from point